Technical Staff Member, IBM Research, Dr. L.V. Subramaniam. So over to you, Geeta. We are sure we all are interested to learn more about the emerging technologies. This is a post-lunch session, so request you to keep us engaged. So that, time is around 3:30, before the 15 minutes question.
2:29.
Okay, so 3:15 to 3:30 open for the questions.
Yeah, sure. Thank you, Varsha, and good afternoon, everyone. I think it's a great privilege and an opportunity to really speak and talk in front of all of you. So thank you so much for giving this opportunity. And Varsha has given me 5-time instruction that we know IBM, don't talk about IBM. All right. So I have a question for everybody, just to see if everybody is awake. Can somebody tell me that how old is IBM as an organization? Anybody? How much? More than 70. All right. Anybody else want to take a guess? 100 plus. Close. Anybody else? All right. So I think 100 plus, it's 111 years. All right. Great, right? And that's where you will see, because when the topic came as an emerging technologies, you can see that what the evolution IBM has gone through over 111 years of continuously transforming, continuously embracing the new technology, whether it was starting from mainframe to now we have Z16 to blockchain to quantum, right? All of that is a big spectrum which we are talking about. So what we will do today, we will spend about the time which has been given to us. We'll stick to the time, and of course we'll take the Q&A. I'll talk broadly about the technology and the emerging technology which impacting the entire industry. Then we'll do a little bit deep dive into quantum and around the blockchain. And I think our promise is that it is not going to be deep technical. It will be more how it relates to business. Because absolutely at the end of the day, technology has to fuel the business. Otherwise, I think, and I keep saying that we should keep thinking about that tech that matters to us, right? Because there is a lot of technology which keep emerging. So my introduction is done. So this slide is actually saved for me. So look at this chart, okay? What we just tried to do, we took a lot of news articles and everything saying that what is getting spoken about in India from a technology standpoint, right? Look at this, you will see so many things, which is quantum, which is AI, marketing automation, robotics. But if you see the top of it, we are saying 3 things, and that's where I think absolutely RBI is on the right journey, where we are talking about quantum, cybersecurity, and automation, right? I think in the opening speech we spoke about that you have a vision that the facility which gets built should have a 30-year plus vision, right? And I think quantum absolutely fits in there, that how it will start now and it will be future-proof for next 30 years, how we will look at that vision, right? So this chart actually tells us that it's an ever-evolving area, emerging technology, and these 3 things right now are of prime importance, and people are really talking about it. And we'll go a little bit deep into each one of this, that how and what role each one of these technologies is playing from an industry perspective, right? And I think if you look at this chart, it's a very simple chart which is saying that with the infusion of technology, how the entire traditional banking business model has inverted, right? If you see, initially it was largely into 3 buckets, which is back office, and major investment used to happen in core banking and those core applications from the banking side. Then we have the products, and we had customer and channels, right? Come today, you think about that, we actually think more about customer ecosystem. We have so many banks venturing into the digitization of corporate, retail, lending process, KYC, doing the agri platforms, right? Having the agri platforms or platforms like which are complete digitization part of it we are talking about. So there is so much investment happening on the customer ecosystem side, but this is all is fueled by technology. If technology was not there, this was not possible. That how it's shaping up and bringing the new business model. The second is cognitive products, which are data and AI driven. I think I'll just simplify by saying that when we say cognitive product, it's about that how continuously we are evolving products by taking the feedback, which means what demographic is buying that product, right? Is it the Gen Z or is it the elder generation? Which generation is really buying these products? And what packaging goes, which means if I am a salaried person, is the financial product I largely buy as an insurance product, right? Or do I buy the travel stuff from you, right? So all of that is the cognitive product layer where you are continuously improving the product and packaging in the offering part. And of course, at the end of the day, the back office, the straight through processing, as we call that, however, how much, whatever digitization we do on the front, but if our back office is not enabled to support that process, the time taken to complete that process will be very, very high, right? So this is actually is possible completely through the technology intervention. And if you see the bottommost layer, I think I wanted to little emphasize on the bottom layer, which is earlier we had all monolithic core systems, which were functional in their own silos. Now today we are talking about a hybrid multi-cloud architecture. I'll not go into the technicalities of it, but what we are saying is that how different departments interoperate, right? So what is changing? Digitization was on the road, people were doing digitization in the silos. Today we are talking about each department transparently interacting with the other department so that the processing could be straight through, right? And the different workloads run on the, and need different computing. Right? So if you take RTGS, which Ravi sir was talking in the morning, today that requires like very high computing. It runs on the IBM Z series today, right? Because the workload is very different. Now I may not need a Z series just to do a front office portal, because it can very well run on a power system or on a server. It doesn't need a capability like Z to run a customer portal, right? So you're dealing with the different compute which is suitable for the different applications which come. So it's a very, very hybrid environment. Few workloads can go on cloud also, but not all. So what is suitable for cloud should go on cloud. What should stay on the on-premise should stay on-premise. So that's the inverted model we're talking about. Now this is a very business-centric chart, and maybe I just give you 30 seconds to absorb this chart. This is a study done by IBM Institute of Business Value, that how and what are the industry imperatives from a financial sector standpoint. And we have one of the co-authors, Swati, right here. She wrote this white paper along with a couple of other authors, where we are talking about that there is a real industry reinvention happening in financial sector, and I'll come to that, what technology is impacting. We spoke about customer-centric business models, because everything is revolving around customer, right? Saying that what does customer need? Is he an agri customer? Is he a Gen Z customer? Is he an insurance customer? And accordingly, we are continuously packaging. End-to-end digitization, we are talking about that. New workforce, new workplaces, right? And we say this is nothing, and sometimes I like this quote saying that actually nowadays we don't know, sometimes robots are our colleagues. Right? We do the HR bots, or we do the IT bots who are actually helping us. So at new workplace, while we are all collaborating, sometimes robots are our colleagues who are working with us and helping us to collaborate better, right? So new workplaces, then sustainability. In the morning speech, I heard so much about sustainability, that you will be only constructing 14% of the land, greenery will be maintained. So how do you really be a responsible enterprise also when you talk about the sustainability part? Security, fraud, I think you've heard so much since morning, so I'm not dwelling deep into security, but we'll talk in the context of blockchain and the quantum part, that how the quantum safe algorithms now are working from a security standpoint, right? So if I was to map each one of this with the technology, right, because this is what we are talking about from a technology perspective, I'll first go on the customer-centric one. So if I see customer-centric, it is omni-channel experiences, what it is coming, and how we are opening up. So let's say when we are talking about RBI Innovation Hub, where fintechs are coming and there are sandboxes on which they are testing and doing everything. So how do we orchestrate everything through the APIs, right? That the fintechs are able to connect back or banks are able to connect back. So that's the entire API part. Intelligent automation is about business automation, people automation part. The workplace, as I said, which is the robotic as the new colleagues or the robots as the new colleague. I think one important point, when we think of data and AI, everybody talks, right, saying that data is important, data is the new oil, everything we talk about. I think what's important is that are we playing ethical AI, which means how we store data, what we do with the data, what kind of a samples we are really picking up so that the sample itself is not biased. See, in AI, you run at a risk of having sample itself biased, right? So the sample of the data which you are picking up and what kind of a transparency and governance comes in, I think that is very, very important. So I think most of the people are doing data and AI, but are we applying entire ethical AI framework? That is becoming critical. Sustainability, yes, at the end of the day is function of how much data you are able to capture from the field so that you are able to report out that what kind of a carbon emission is really happening. So I'm not going into each one of that in the detail, but these are the different technology, and of course on the blockchain and Web 3.0, you will hear from Swati as she comes in that when we are talking about digital assets, cryptocurrency, or we are talking about the NFTs or other stuff, then how the Web 3.0 and the blockchain is really going to play a role. And platform economy, when we're thinking about ecosystem, which means today also, like we are all here as one of the IBM as one of the vendor has come here, right, which is RBI's ecosystem. So we are coming here, we are interacting with you, we will participate in your skilling initiative, right? So like that on the technical front when we go, so we are saying that RBI needs to probably really open up the entire microservices architecture for fintechs to really connect. So these are various technology, and I don't want all of you to remember these technologies, but I think they are all impacting in some or the other fashion the business part of it. But what is more important, which I think LV is going to throw some light on it, is that while we are evolving on the business side, we are evolving on customer, expectation is very high. The question is that how is our computing evolving? Because the more data you have, the more computing power you need, right? So for us to have more computing power, the whole computing is evolving, and you see that RBI is actually an early adopter, and now they will go on Z16, and we're talking about early conversations on the quantum computing part of it, right? Now this is my last slide before I invite LV. I think wanted to thanks on behalf of entire IBM that RBI is a fantastic partner, longest partnership which we had with you. We have worked with you since 2007, you can see on this chart, and I think this journey is continuing, and I think with this partnership around which you are opening the skilling COE, we hope that we'll work even more closely with you and do lot many technology, innovation and co-creation along with RBI. Thank you so much, and with that, LV, if you can come on the stage and talk about the quantum. I'm available for any Q&A, which we'll do in the end.
Hi, good afternoon everyone. So in the next few minutes, I'm going to talk about a new computing paradigm. So we're all familiar with, our laptops, our mobile phones, and supercomputers. But there's a completely new computing paradigm called the quantum computer. So on the one side, you have the classical today's computers, and we all know what they can do, right? So we can do a lot of computational work on that. But there is a new kind of computers which bring with them an immense power, okay, to solve some of the unsolved, some of the most toughest problems that are there. So what I'm going to do is tell you about how this computer works a little bit, and then talk about what it can do, right? So those are the two things that I'm going to cover today. So, as I said, computing is for the first time in the history of computing, it is diverging. Two different platforms are becoming available. One is our classical supercomputers, mobile phones, and laptops, and the other side is the quantum computers, right? And what is expected is that we expect that these computers can solve some of the toughest problems, okay? So I'm going to allude to some of those. What are those problems? And what are the challenges it's going to, pose, for example, to cyber security? So here are, 4 areas where, I think. So there are multiple areas that it's going to affect, but I'll tell you, at a very high level, quantum computers use quantum mechanics for computation. What is quantum mechanics? It is how nature behaves, okay? So when you look at atoms, they use quantum mechanics to interact with each other. When you look at new drugs, when you look at new fertilizers, you look at battery materials, all of these follow quantum principles. And so what happens is you cannot use classical computers to do some of these things, okay? And that's where quantum computers come in. And also in the area of finance, there is a lot of work that is already happening using quantum computers. So this is the, it used to be the second most powerful, now it's the 4th most powerful. So supercomputers, as we know, evolve, they evolve very fast. Every 2 years, Moore's law, we would all have heard of Moore's law, computational power doubles, okay. So by Moore's law, computational power for the past 60, 70 years has been doubling every 2 years. In quantum, it is doubling every year, okay. So, which means that, quantum is also very, very fast, it's growing and it's exponential in growth, okay. But using the supercomputers also, there are several problems that we cannot solve today, right? And that's where quantum computers come in. So the question, natural question is, are quantum computers going to replace today's computers? They are not going to replace them, but they're going to be used to solve some of the toughest problems that today's computers cannot solve. So I'll not dwell on this, but here, there are problems which we can solve today, okay? And so we are talking about cyber security here. What is the factorization of 21? It's 3 into 7, right? What is the factorization of 49? It is 7 into 7. This factorization is what internet encryption today is based on. The fact that if I give you a very large number, 503752889, a huge number, a computer cannot factorize this number. And the keys that we use, for example, for doing transactions on banking websites or any websites or WhatsApp encryption, all of that is done using the fact that large numbers cannot be factorized on today's computers. How long will it take? A 2048-bit large number will take 6 billion years to factorize on a supercomputer today. And that's the fact we use to use factorization as the mathematical principle for doing our encryption. So all our data today is secured using encryption principles that follow factorization. I told you it takes 6 billion years on a classical computers. Does anyone want to guess how long it will take on a quantum computer? 6 billion on one side, and on a quantum computer it will take
6 months.
okay. Okay, so I heard 6 seconds somewhere. Well, it's not 6 seconds, neither is it 6 years, it's about 6 hours. Okay, and this was proven in the year 1993. Okay, so many years back, 30 years back, it was proven that quantum computers can break today's encryption. number one fear, actually 2048 bit number. So it's even bigger than whatever we have today. Okay. Now, so what is the biggest fear today? Okay. The Indian government, for example, we've been speaking with, the number one fear is that China could be collecting our defense secrets, our financial secrets, and just storing the data. They don't have a computer today. But once that quantum computer is able to run this algorithm in a few hours, all that encrypted data is open. You can see it. So all the national secrets will be out in the open. And national secrets are not saved for the next 2 years or 3 years. They are for 30 years, 40 years, 50 years. So how do we secure our data? And how do we secure transactions? So for example, the UPI network, millions of transactions. India is the largest digital payment, has the largest volume. All of that becomes vulnerable to quantum computers. So this is something, quantum computers as a threat, but they also solve a lot of problems. Okay, so there are this class here, where you are able to simulate nature, which you can never do on a classical computer, are the class of problems which are very, very exciting. New drugs, today how do you discover new drugs? You use test tubes, you pour a molecule and you see how it interacts. You give it to a person, do clinical trials, see how the body is reacting. Why do you do that? Because the classical computer is using zeros and ones. What is the quantum computer using? I'll come to that. So there is a limit to the bits, okay? So that's the message here. So what is so special about the quantum computers, okay? So I don't know, how many people know what this year's Nobel Prize in Physics was for? It was for quantum, okay? In 1935, Einstein said something called entanglement is impossible. He called it spooky action. What is entanglement? I toss a coin, you toss a coin. If they are entangled, by looking at my coin, I can say what is your coin. If I get heads, you get tails. Okay, so they are entangled. That entanglement, I can do it here, and you need not be here. You can be at the other end of the universe. And entanglement is still possible. And this was proven by the scientists who got the Nobel Prize this year. 2022 Nobel Prize in Physics was for quantum, okay? And what does this mean? This means that, science has come up to a point where you are now able to use it in a way that you can solve some of the very tough problems. There is also a philosophical question to this. In our scriptures, you read a lot of things like, you can read somebody's mind. You can, through your thought, you can make some things move or do things. All of that, many people believe is entanglement. Something which was proven this year in the Physics Nobel Prize, it's all coming there, okay? So as in the morning lecture I heard 30 years you're looking ahead, you have to consider quantum computing because it's coming, it's already there, and I'll show you how it's growing. Sorry, how much time do I have? I'll take 5 minutes. Okay, so the other question, so which country has the highest number of software engineers? Anybody? Okay, India. I heard India very confidently, but it's not yet there. 2024 will be the largest, okay? How long did it take us? 1962, the first IBM 360 arrived in IIT Kanpur, 60 years, okay? So it took us 60 years to become the big one in software. You're right, yeah. All are Indians, that's right. But this will be really a milestone because a lot of the technology that gets built here is what the world is going to adopt. You know, the very important impact of India becoming the number one in terms of the software people is that any technology, you take Python, you take C++, you take blockchain, unless this population adopts it, it's not going to succeed, okay? So it is very important for organizations like RBI to actually set the tone. You know, what is our country going to do in the next 20 years? It's very important to channel all this energy that's there and push it in a way that, you know, we become not only in, you know, the number of software engineers, but also in terms of, you know, the services we offer, in terms of the products that we have, in terms of adoption of new technologies and coming out with new innovations. So it's very important that we channel all this energy, and that's where the responsibility for each one of us is. So this is an important chart because it's showing how fast quantum computers are growing. So you know about bits. Bits are zeros and ones for classical computers. What are for quantum computers the equivalent? They are called qubits. Qubits, okay. Qubits, today we are at 127. In the next 2-3 weeks, IBM will release the 433 qubit computer. Next year is 1000. And what does that mean? So I'll go here. This is a chart from NASSCOM. NASSCOM is saying that the inflection point for quantum computers is 2026, 2027. Okay, that's not very far away, 4-5 years away. What is IBM saying? IBM is even more optimistic. We are saying it's happening next year. Okay, so the inflection point for quantum computers is going to happen within our careers in the next few years, and it's going to shape how the future comes out, right? So this is again a NASSCOM report, which is saying that by 2030, there is a lot of value that's going to get unlocked in India. This is an Indian chart. There are several applications, I'll not go into them, but I'll just sort of end by saying that we are already working with the Indian ecosystem. We worked with the RBI Innovation Hub to figure out what are the use cases for India. Okay, so I'm showing you a chart here for T-bill, treasury bill estimation, but we are also discussing with the Indian banks and others here to figure out what are the use cases that are important for India. You know, for example, the unbanked. You know, how do you give loans? How do you parameterize those things? How do you mathematically model some of these things? And that's where quantum computers also come in, right? So I'll stop there. Thank you very much, and I'll call my colleague here. Thank you.
I have one query before you.
Yeah, sorry,
Just
go ahead.
now you spoke about this one quantum computing that is going to break the quadrant level of encryption in 6 hours. That may happen after 4 or 5 years later on. My point is that when this is the power of quantum computing, so are we also working on some different algorithm, encryption algorithm, because presently we are using RSA.
Yes.
So what different algorithm that we are going to develop so that it can bypass this supercomputing power? So is any work going on that also?
Yes. So, so as you rightly pointed out, you know, there are these encryption schemes which are there today, which are based on factorization. There are new algorithms which have already been developed and standardized also. So there are some by IBM also. They work in the lattice dimension. You know, lattices in the n-dimensional space, not the 3-dimensional space that we have. In an n-dimensional space, you mathematically solve and give these keys, and they are not breakable, at least not yet, by quantum computers. Yeah, thank you. Sorry, my colleague reminded me I have a demo, but I think it's a bit technical, so I'll not go into that. So, yeah, thank you. दिखा दें, ठीक है, चलो. नहीं समझ आएगा वो अच्छा है. Can you tell me where it is? अच्छा.
application in the finance domain. Broadly, we work
Okay, so this is my colleague Anupama. Okay, she's been working on large graphs. Okay, what are large graphs? Now this is shown on Ethereum. Well, it need not be Ethereum. We have picked Ethereum because it's open source. You can have the data out there and we can actually show results on that. But equally well, we are working with IIT Madras to look at UPI transactions. Okay, so what are these UPI transactions? What are Ethereum graphs? They are large graphs, okay? I give you money, you give it to somebody else gives it to somebody. So it becomes a large graph of billions of nodes. Now, out of these billions, only a few bad nodes are there. You know, not everybody is a crook. There are very few crooks out there, okay? So out of the billion Indian people who are doing transactions, there are maybe a few hundreds who are actually trying to break the system, trying to take somebody's money in a wrong way, or making, fraud or those kind of things. So the work here is to detect fraud in a large graph, okay? Now this is a very, very tough problem for a classical computer. Why? Because, for two reasons. One, because it's very large, okay? It's a huge graph that you're looking at. Number two, the features. How do you say that I am a crook and the other person is a good person? It is based on the kind of transactions I am doing. I have a signature. As a crook, I might be, taking money by doing some sort of a fraud or whatever. How do I recognize those features, right? So the idea here was to recognize those features and to see how traditional AI machine learning does against quantum AI, quantum machine learning. Okay, so that's what this was. And what we did was we actually ran this on. So I'm actually going to show you some code here, okay? So what we do is we run what are called quantum support vector machines, which run on quantum computers. Today, quantum computers are actually accessible over the cloud to anybody. You can also go and start using a quantum computer. All you need to know is Python, okay? Python, there is an equivalent library for quantum called Qiskit, okay? So you use Qiskit and you start coding. And you'll be happy to know that India is has one of the highest number of Qiskit programmers across the world. You know, when IBM opens any portal, within 15 minutes we have to close it because Indian software engineers go and register for it. You know, there's so much enthusiasm out there, and we really, and that's why it's crucial that organizations like RBI provide direction to this young generation that really wants to do something, okay? So, okay, now this, so I'll just go to the end to say that the results here were very encouraging. It was much better than classical computers, but not at the level of 8 billion versus 6 hours. It was more like, 12 hours versus 6 hours at this point. But this is, remember, using the small quantum computers we have today, okay? As the power increases every year, doubles, or even faster than double, that inflection point that NASSCOM and IBM talked about, 2026 NASSCOM talked about, IBM talked about 2023, it's not far when, that exponential advantage is there. Okay, thanks. Just look for you. Come.
After such an interesting session, LV, I have no pressure. I don't know how I'm going to make this as interesting as that. But while we are looking at this, I'll start with something little cooler, not as cool as quantum. But have you heard about metaverse? Okay, can somebody tell me how old is the metaverse as a terminology? "30 years. It was actually introduced in a novel, in a movie, Snow Crash, which was there. 20 years back, we had something called Second Life, which was metaverse. But obviously, the technologies were not yet matured, and hence it did not go. And today is where the metaverse is coming into picture. The reason I really reminded me also was because he talked about end dimensional. Let's talk about multiverse. You know, Doctor Strange, multiverse, at least till there, right? So multiverse, metaverse, all synonyms here. Okay, so I will absolutely try to keep it, I think all my colleagues have said, we will keep it as less technical as possible. This is what Geeta talked about of the new internet that's coming. Yeah, the new era of internet. We talked before us, we have seen, especially generation of ours, we've seen the transition. Web, you know, the .com times when we used to read static web pages, to today when you read, write, interact on platforms like Facebook, but are centralized. So that's the Web 2.0 that we're talking about. Web 3.0 is a step ahead. Number one, today these servers of Amazon, Google, and Google is right at the top of mind with all the news that's come around Google, but all of these are more centralized in nature. We are talking about platforms that are going to be distributed, right? It's going to be decentralized, number one. Number two, we are not just going to read and write, we will own the data, which means that what I write on Amazon, or sorry, Facebook or anything else is going to be my data. To be able to do that, you absolutely need to have an identity that goes across these platforms and networks. So concept of, you know, self-sovereign identity kind of an identity is very, very important. And of course that when you do all of this, we've been talking about internet of information and internet of value for some time. This is where the real value will come. You're talking about virtual economies being built on this network, right? So that's the direction that the world is going to. This is being defined as we speak. Of course, there's a lot of evolution still to happen. But before I go there, so a lot of these concepts that we talked about, decentralized, virtual economies, we talked about owning the data, the self-sovereign or identity, etc., are based on blockchain, and hence I'm talking on blockchain. So what is blockchain? Simply, it's 4 key elements. It's a ledger that is distributed on different nodes of participants in the network. It is a distributed ledger. Every transaction that you do on this ledger is based on a consensus mechanism, hence extremely secure and immutable. Smart contracts is a means of putting those business rules and logics that can be executed automatically on it. 4 simple key elements. How does it work? Every time I record a transaction, it creates a block of hash data, cryptographic data, whatever that you call it. Every time a next transaction comes, it is linked to the previous transaction, and so on. Hence, it creates a blockchain. So it's a chains of block, which is called as blockchain. There are variants of those blockchains, but I will, if you just put them into buckets, there are 2 big key ones: private blockchain, public blockchain and permissioned blockchain. You're very familiar with public blockchains. I think all of us have heard about things like Bitcoin. That's the public blockchain. permissioned blockchain is something where organizations like financial institutions, and serious businesses, that's where they invest. Of course, they are more secure. So what you get with blockchain is greater trust and transparency. Again, a basic framework of Web 3.0. What you get with that is security. And third is, of course, the efficiency. We are talking about a network and an ecosystem coming together and trusting each other. Hence, obviously, efficiencies increase. We are not going to solve the world's hunger or poverty using blockchain, please. That's definitely not going to happen. What we are addressing and what can we address with blockchain are three key buckets again, three key areas. Provenance is no-brainer. Since you can record everything that happens, there is a provenance to any life cycle that you take, whether it is supply chain, whether it is a financial transaction or anything. Provenance comes by default into it. And it's being used, of course, as I said, traceability, auditability in a supply chain. It can be used in the trade and trade finance. A lot of times we've heard sustainability these days. Sustainability, right? How do you know in the entire value chain what is your carbon footprint? Which are the sustainable institutions that you're working with? So that's another key pillar here. The second is the identity, the self-sovereign identity. The easiest way to explain a self-sovereign identity is it's an approach where I own my credentials and only I can give the consent to use it to any third party. And that third party could be an individual, institution, or platform or a service provider, anything. That is the big difference. Now, of course, there have been multiple use cases. In the COVID times, something like digital health pass was the most commonly one. But any kind of identity is what a lot of governments are already using, which is, it could be national identity, it could be my driver's license, it could be a simple credential where I've worked, am I an engineer, have I done MBA, I can actually verify all of that using this technology. And the third pillar is tokenization. Again, I know Bitcoin is the most common over here, but the simple way to explain this is, I have a digital asset. How can I tokenize that in fractions for me to be able to transact with it or operate with it? That's the basic concept of it. Cryptocurrency is something which is most common, but there are many, many more examples of tokenization. The central bank digital currency is one classical one in a legal framework. We've heard about lots of banks. We've heard about, in India, of course, we have commercial banks, payment banks. Have you heard about plastic bank? That's one type of, you can really create with the tokens. And I'll take a few seconds to talk on that. This chart is not to tell you about IBM, while it is, a lot of our clients. It is only to tell you that it goes across industries in various spaces, right? It is across your supply chain, across your financial industries, across insurances and, sustainability and all of that. I've kept some of them here. Most importantly, in the financial services, the most common use cases that we've seen is trade and trade finance, central bank digital currencies, digitizations of anything. Of course, we've seen a lot of bank guarantees or the letter of guarantees being digitized. Where there is an ecosystem, you need to get trust on. Plastic bank, as I talked to you about, and all the pre, post, netting, settlement, all of them, where the reconciliation can disappear, is also one of the key use cases that we can look at. One quick example I will take. This is a company that, it's a joint venture. Ligon is its name. It is actually a joint venture between all the big Australian banks that have come together to digitize the bank guarantee. Now, digitizing the bank guarantee, especially in a legal framework, because we worked with them, we know that it took 6 months for the actual legal framework to come into place. The technology was the easier piece. So getting that, and then from 1 month of that whole guarantee process, it actually came to 1 day. And the 1 day is also not because of technology, it could be done in seconds and hours, it's more about the whole process that is involved into it. So that's one. The second one, TradeLens. This is a global supply chain platform which gets ocean carriers, freight forwarders, customs, ports, terminals on one platform. That's the beauty of blockchain. You can get the ecosystem together. And I will not talk much, but instead, and I hope I do this right. Sorry, let me first show you. What happened? Huh? Okay, while Satyam does that. Okay, so this actually gives you a live counter of how many events that has been published, how many documents that has been taken care of, and how many containers that we have shipped on TradeLens. It'll give you a good view of that. No? Okay. What is, what is important is when you get this ecosystem together, first it gets everything digitized. Second, what you're doing, I remember, I first started my journey in financial industries with EDIs, Edifax. You remember Edifax? So Edifax is where, when you have this supply chain or an ecosystem, that's what you transfer between each other. This almost removes that whole piece. So this is the TradeLens platform. I'm sorry. You see this? These are all the partners and individuals that are on this platform. There are more than 320 ports today on it. In India, the Mundra Adani port is actually the one which is there on TradeLens. If I look at just the customs, and so I'm sorry, I'm finding it a little difficult to read this, but you'll get all of these. This is the live counter. The containers that are being processed, the events that are being actually done as we speak. And a quick video here. This is really
In the industry, this is a really exciting tipping point. We've achieved something that we've never been able to do before. That is of massive value. The shipping industry is a really central node of the global supply chain. Everybody in the world needs shipping, but they don't always realize it.
The shipping industry is connected globally. It is connected to sellers, suppliers, to the oceans, to the land, to the air. You can't speak about global commerce without looking at the logistics and operations that power it. So we are part of a bigger thing.
A lot of products today, when you order them online or go to your local retailers, are actually delayed because of the difficulties that the supply chain has to cope right now. New dimensions, regionalizations, trade tensions, making supply chains more complex.
When you move a container from one country to another, you have to go through customs, to the ports, to the terminals, and to the customers. And everyone needs access to information and needs to provide information to others along that journey.
It's an old industry, very much built around personal relationships and paper.
It is very cumbersome, and we need to become better connected as an industry.
a typical transaction, you could have 20 or 30 stakeholders or actors.
You will have to follow different processes, you will get your data in different formats, different fields, different timelines. As a result, we see the whole workflow suffering from inefficiencies. And these inefficiencies, unfortunately, get passed to the consumers at the end.
From a digital standpoint, there's thousands and thousands of data connections between carriers, customers, vendors, and if you try to bring them together to speak the same language, it's very difficult if you don't establish the rules. And I think that standardization is probably the only way to build that foundation.
We need a tide to lift all boats here and really generate a different outcome end to end, because the supply chain is only as strong as its weakest link.
If we don't do it together as an industry, then it's never going to get adopted.
And that's why Maersk, a lot of the shipping lines, and IBM have joined forces to create a platform like TradeLens. TradeLens will really solve a lot of the problems that have been plaguing the globe.
I'll take a pause here.
So basically more than 50% of the traffic, actually of the shipping traffic and the ocean carriers, etc., actually falls in this. Another example is the IBM Food Trust, which is again a similar ecosystem. I won't get into the details of that. Now this is what I was talking about, the plastic bank. Concept is very simple.
Concept is very simple. We're talking about somebody giving plastic, basically depositing plastic. In return of that plastic, the individual gets a token, and that token can be used at many other retail or other outlets for redeeming those tokens. And this plastic that has actually come in is actually used again by companies like Unilever, which is a mechanism for them to reduce their carbon footprint as well. So very simple logic, but can be done beautifully by using this technology and the concept of tokenization. So we talked about multiple use cases in the vertical side of it, various industries you have it. Of course, there are a lot of places where there's convergence of industries and so on, but there are individual platforms. We are already seeing the platforms talking to each other, which is if I have a TradeLens and I need to get an insurance, I will talk to a different platform, or for that matter, trade finance, or for that matter, if I have the food supply chain to talk to and so on. So the next is where the networks will talk to each other. Of course, interoperability becomes key when these networks are talking to each other. And hence, when you do that, that's the digital identity that I was talking about right in the beginning that has to grow across different networks. It has to be digitized, and of course, the assets that we are transferring each of them has to be digitized. And hence, I bring an analogy on the metaphors. The way it relates to me, and probably it relates to you, is when iPhone was launched in 2007, we had cameras, we had operating systems, but I remember 20 years back, I was using either an SMS phone or a WAP phone. But what iPhone really got together was getting all of these technologies in one box, getting them together to be able to use it. That's exactly what Metaverse will do. That's exactly what it's going to do. There are technologies that you see, whether it's blockchain, we talked about AI, 5G, Edge is right here. All of these technologies, we have augmented reality, the virtual reality, the mixed reality, all of that we see in the gaming boxes today. That is what it will come together. So as I said, when I was using a WAP phone or an SMS phone, I obviously didn't imagine that I'm going to use my smartphone for almost everything. But that's what is coming, right? That is what we will see, and that's what we need to work on. Are there challenges? Absolutely. Security challenges? Absolutely. I mean, the biggest problem today is the cases that are being registered on Metaverse today is of assault, a sexual assault. Right? So things like this have to be, there are standards that needs to be created, these technologies have to evolve, but it's right here. I will take a pause here with just this slide in front of you. Thank you.
Thank you, Swati, for such exciting session. I'm sure this was the future which we are seeing, and there will be n number of questions. But before we start, can I request Shailendra sir to come and explain us about the experience center, where all these technologies are being planned in the data center. Spend few seconds. He's not around. Sachin sir, will you like to do that, please? Experience center, where we have these technologies.
Thanks for
No, actually he's showing you the future. I just thought that is going to be more relevant. Sir, next time you don't have to travel to the data center. Shailendra sir is
We are going to make it virtual, na? So you'll lose the incentive. Like what we started video conferencing way back in 2005, August we started, we launched on 1st January 2006. So it was thought that with that all the physical visit will get, no, it's just a complementing technology, it will not stop that. But what we are talking about the data center, what we are going to build in Khurda, Bhubaneswar, is that the idea came from Shailendra sir, of course, why can't we think of something, what Metaverse is called as an immersive technology kind of a concept, where we will have a literally virtual tour of all the facilities, not only the virtual tour, but understanding the entire concept behind that. Instead of taking you around, yes, this is UPS, this is that, and all this thing, you are getting immersively involved in that things that is being planned for that. And we are working on that, not yet finalized, but we are putting our mind to that work. I think something good will come out. It will be one of the key feature apart from the data center for us to visit and get the first-hand feeling of the data center and other technological concept in a very easy fashion for us to tell that. So that in brief.
Yeah,
I think
thank
that
you.
suffice.
Thank you so much, sir. May I request IBM team for the question answers and shoot out questions.
What you have told is augmented reality,
Yeah.
and banks are using it. You are sitting at one place, you are using the technology, and then you are doing banking by visiting the branch, meeting the teller, making the payment, withdrawing the money, everything is happening by sitting at one place. This is augmented reality banking.
Yeah, so the kind of a metaverse kind of things are immersive one, where you will have all the things you are virtually visiting. In fact, I was discussing with my dad. She has told me, Papa, why do we have to go to the school? Can't we have something, this kind of thing? I was always working from home using whatever technology we had, WebEx. So that's the concept, we don't have to visit anyone sitting at home. We are actually sitting in the classroom or sitting in the conference like this, interacting with each other. Of course, she has a different mindset. I'll send my avatar there. I'll have some other thing. So a lot of things are coming there together. Yeah, right.
Thank you, Sachin sir. And IBM team is around here. Vishi is also, Vishi, please be there. Vishi is our go-to man for anything and everything in IBM, so we want you to be here. Answerable to RBIs. Sir, any questions?
Check. Very insightful presentation by the team, and many thanks for that. My question to LV. You talked about the quantum, and the way I am from economics. My question is, one of the basic tenets of economics is money is neutral. It's a veil. It has no impact on real sector. And a lot of our modeling and all depends on that paradigm. But with quantum, economics coming up now, money is seen as a quantum object. What you said,
Entanglement.
Entanglement is a very critical feature of money. I am sure with this concept, the traditional economics is going to go for a complete overhaul. And so what is your take on, that quantum computing having an impact on theory as well?
Yeah. Right. So, in fact, that's a very important point, right? Because quantum computing is based on two principles. One is superposition, where the qubit can be in multiple states between 0 and 1, and the other is entanglement. And what we have, I'm not a financial expert like yourself, but what I've been told is a lot of financial instruments also have similar properties, like you said, right? And that makes them very, very, so for example, Markowitz theory is used for portfolio optimization today, okay? So how do you, what assets do you have in gold, how much in bonds, how much in, currency, all of that. So that Markowitz theory apparently can be very much better modeled using, quantum, as you said, right? But as I'll tell you the honest thing about, as a scientist, many of these, financial domain knowledge is not with me. I don't know many of those things, and that's why we have started reaching out to RBI Innovation Hub and to RBI and others to tell us what are the the tough problems there, so that we can really address them. So that's my answer, because I really don't know that much about finance.
I had a question, not a question, just a query regarding the blockchain, where the use case of trade finance. Like hundreds of documents are required to be exchanged physically if it is done otherwise, but in blockchain it all becomes very easy and quick and no physical exchange is required. So since you know about the globally how it is operating, it's of course catching on, but in your estimation, like how much of trade finance globally is currently being conducted on blockchain, the documents, documentation, etc., and how much is still remaining to be done? I mean, I think it would help a lot given the kind of problems we've seen in the global supply chain. So would like to have some response on that.
So when you say trade finance and trade, I would consider it two different ones. Trade, as I said, are many organizations. I think more than 60% of the trade, because we have so many ocean carriers on that, are on the platform. From a trade finance perspective, I think we are not more than 20% yet. Yeah, and there is a 1.8 trillion gap globally in dollars of the trade finance part of it, especially because of a lot of frictions that exist today. The SMEs who can't get it, rejections are higher, you can't connect and get visibility, and so on and so forth. So there's a lot more that we can do, if that answers your question.
Like, is there any body or something which is trying to, kind of coordinate all this and ease out the stumbling blocks?
International Chambers of Commerce is working on it very seriously. There are standards being formed, and IBM is part of that, that framework that is coming in.
So, ma'am, we just concluded the proof of concept with our Reserve Bank Innovation Hub on trade finance as a use case, where we demonstrated trade finance on blockchain network and how it shows the improvement in efficiency, digitization, and things like that.
Thank you. Any more questions? Okay.
To have a certain, we don't have an ISO standard for that right now, wherein internationally we can implement that, okay? So it's not there. That's a one stumbling block.
You should get in touch with them, that's
So
all.
I have discussed with them, so that one part, and second part is pertaining to the quantum computing. Slightly more elaboration on the safety and security which we have to take care.
Security in blockchain, is that what you're saying?
No, quantum computing.
Okay, so in quantum, in fact, that was a question you had also asked, right? What are the solutions? So there are solutions which already exist for encryption. Okay, for encryption, there are now new standards. If you know how long our current standards took, they took 20 to 30 years to get established. For quantum, the The hope is it will not take 20 years because by then, things would have been broken. So we need to move much faster there. So that's one thing there. But in other things like DDoS attacks or any kind of attacks on cyber security implications, quantum machine learning, I showed one example on Ethereum, but there are similar things that we are doing for, quantum attacks also.
Can I just add a little joke here? So I saw a series, and I just doesn't get on my mind right now. It's an English series, which had basically an island that they would take you to, where every hour is an year. So the number of hours you spend on that island is basically the number of years you've gone there. And that was of course it's very hypothetical obviously, but it was illegal. And the key thing that they were doing was to actually test the medicines. It was for the medical research. You won't have to do that with quantum, I assume and presume.
Risk. See, the risk is definitely in the cyberspace, right? Because today's encryption gets broken. So all the encrypted, all the secure data is gone, okay? No security there. So that's the risk. The opportunity is that, you are able to solve other problems, like DDoS attacks or any kind of attacks on your systems, you're able to predict them much better. Right? So those are the sort of the two things, and both, people have started working on, so I think it's, that's a good thing.
My question was more like if the not so good hand get the hand of the quantum computing, how we are going to save ourselves? That was the question.
Yeah, so I think most of the systems or applications that we are working on now, the clients are asking us, how is it quantum safe after 10 years, right? And a lot of times, because these are long-term platforms being built, especially the new platforms, defense is one area that we hear very often from, of how you're going to make the system. So it's something that we are learning as well, of how it will really, there are a lot of risk. As I said, metaverse you asked about, lot of risk. Risks in terms of course, can you get on metaverse and, disguise yourself as a woman instead of a man? Very simple thing. Even the metaverse actually, you can feel it. There are technologies where you can actually feel it, so you can touch while I don't want to be touched. Right? So a lot of those risks do exist, that exist today, will be even more tomorrow. We all have to work through those standardization and security stuff.
Thank you, Geeta. Thank you, Swati. I think I'll request CGM in charge, Arun Kumar Singh, to, It was really an interesting session, Geeta, Swati, LV. We look forward to more interesting sessions.
Thank you for the opportunity.
Thank you. Thank you. Thank you to all the participants. This was the last session for the day. I request Shailendra sir to come up and sum up the sessions and have the things karke. this entire day. Yesterday we had a closed door session on the cyber security. Today we had 3 sessions. One was related to the emerging cyber threat landscape. The second one was from the Cisco Zero Trust network, and third one is emerging technology. This is our maiden attempt to have such kind of sessions. So on behalf of DIT, I take this opportunity to seek your guidance, to seek the feedback on how the further sessions should be. You want any inclusions or anything further things to be added, please let us know. I think, yeah, Shailin sir. It is going to be a real metaverse after 2 years.
So what you see me here is I am in metaverse and not the real me. The real me is, I think, somewhere else. So, see, this was the inaugural training program of the Enterprise Computing and Cyber Security Training Institute that we are going to come up at in Bhubaneswar in about 3 years' time. As DG has mentioned in the morning, the objective was to bring such kind of trainings which are not available in the market. In the market means they are not being conducted by any of our training institutions, as well as it is difficult to get other institutes who provide you this kind of training. So this program was planned after trying for at least last 3-4 months or maybe more than that, and all along these 3-4 months our partners from IBM and all also kept waiting when we are going to give a call that you send a team to talk to us. So finally that day is here, and we do hope that more of these interactions and these training programs will be organized by us. The idea was to have the CGMs here for the inaugural program. Next, I think we'll have the remaining regional directors and ombudsmans, etc. to come. And then, as Governor has told us that probably, maybe as the institute comes up, you will probably see that training in this will be a part of the induction program of the officers who join the bank. Like most of us, when we joined, we probably worked in issue and banking or something like that in our initial days. So what we see in the future is that probably people join, they get trained in this institute for a month or so, they probably first work in DIT for a few months and then they go to different departments. So another experience that we'll try to bring in this data center will be about that immersive experience, which will be a mix of simulation, VR, metaverse, and whatnot. So that is still in planning, but probably we are in October 2022. Somewhere in June 24, the data center should be up and running. And probably at that time we'll organize a visit to the data center. Before that, any of us who are interested can make a site visit to the data center today, where we have organized a small picnic with tea for you people. So immediately after this, probably you can see the site. It was good to have you here. Let me take this opportunity to also thank Regional Director Bhubaneswar and the entire team from Bhubaneswar office who worked very hard for last about 10 to 15 days to make this successful. Even after we go back from here, please feel free to get in touch with us with your feedback, suggestions on what more. See, because I don't see it happening that we can get CGMs to come here for a 2-day session or a 3-day session. That's simply not possible. At no point in time it will be possible for us to get people for 2-3 days. So most likely for CGMs and regional directors, it's going to be only 1 day. एक दिन के प्रोग्राम में और क्या कर सकते हैं?
At one point will be little difficult. That's what has been told to us.
So whatever else can be done in a day's program, please send your feedback to us so that next time we can improve on this. Thank you all. Thank you, Varsha.
Sir, after this, we will be going to the data center.
Yeah, that's what I said.
The actual site, we had ensured the transportation available near reception. We all are ready. It will approximately take half an hour to go. We'll be spending 20-25 minutes around there. Some arrangements have already been done there. So approximately 1.5 hours to 2 hours will be required. The PPTs will be shared by end of the day today. And we are again thankful and we look forward to your suggestions. Right now, both the CGMs are around here, so you can please give your suggestions in person, or after going back as well, you can give us on the phone. So thank you so much. Okay, so high tea and snacks arrangement is also there at the data center. The data center site, which is at Khurda, approximately half an hour from here. Those who are not willing to join, tea arrangements are also being provided in the nearby thing. Yeah, this is the opportunity to visit the data center wherein you can say after 2.5 years we saw it before it started.
And when we talk about data center, they would like to know.